Hey everyone, welcome back to our APIGURU channel. For those of you who are new here, I'm Damien Thorne here. On this channel we share everything you need to know about APIs. Today we will explore how to secure APIs with Apigee. Let's get started. Apigee is a platform for developing and managing APIs. By adding a proxy layer to your services, Apigee provides an abstraction or facade that helps you secure your backend service APIs. Apigee provides end-to-end security to protect all points of engagement. Apigee is a platform for developing and managing APIs. By adding a proxy layer to your services, Apigee provides an abstraction or facade that helps you secure your backend service APIs. In this video, we will show how you can leverage the different capabilities to secure all points of engagement. We recommend that you use the Apigee default policies to secure your APIs. You can attach one or more of these policies to your API proxy. Let's get started with the traffic management policies. They help you configure caching, control quotas, mitigate spike effects, and control API traffic. The SpikeArrest policy enforces rate limiting on the number of requests sent to the backend. We strongly recommend using this policy for any API. The quota policy helps enforce quotas on the number of requests a software client can make. We recommend using this policy for any API. And the response cache policy caches responses to reduce the number of requests sent to the backend. Let's move on to the message level protection policies. They let you inspect and validate request payloads to help protect your backend from malicious attackers. The OS validation policy ensures that incoming requests or response messages comply with an OpenAPI 3.0 specification in JSON or YAML format. We recommend using this policy for any RESTful API. The SOAP message validation policy validates XML messages against a specified schema, ensures SOAP messages conform to a WSDL, and checks that JSON and XML messages are correctly formed. We recommend using this policy for any SOAP API. The JSON thread protection policy helps to mitigate the risk of content-level attacks by letting you specify limits on JSON structures like arrays and strings. We recommend using this policy for any RESTful API with JSON as its primary data format. The XML thread protection policy addresses XML vulnerabilities and mitigates the risk of attacks by evaluating message content and detecting corrupt or malformed messages before they are parsed. We recommend using this policy for any SOAP API and any RESTful API that uses XML as its primary data format. And the regular expression protection policy evaluates content against predefined irregular expressions and rejects it if the expression is true. The policy allows us to scan payloads for SQL and JavaScript. We recommend using this policy for any SOAP API and any RESTful API. Let's move on to the security policies. They help you to control access to your APIs. The basic authentication policy encodes and decodes user credentials. Basic authentication requires the client to send a username and password encoded in base 64 with each request. This policy does not enforce basic authentication on a request to an API proxy. Instead, you use base 64 encode decode credentials, typically when connecting to a backend server or using a service callout policy such as the service callout policy that requires basic authentication. The verify Apigee policy enforces the verification and validation of API keys at runtime. It allows only applications with approved API keys associated with your API products to access your APIs. We recommend using this policy when you want a simpler form of authentication using API keys. This is less complex but also less secure and flexible compared to OAuth. API products are the central mechanism for access control to your APIs. In Apigee, API keys are provisioned not for APIs themselves but for API products. An API product bundles together one or more operations. An operation is a group of attributes that restrict access to one or more API proxies based on criteria such as a resource path, HTTP method, and quota. The API key must be included in every request to an API proxy. The OAuth v2 policy performs OAuth 2.0 grant type operations to generate and validate access tokens. We recommend using this policy for robust and secure authentication, allowing fine-grained access control with scopes and roles. The JWS and JWT policies generate, verify, and decode JSON Web Tokens and JSON Web Signatures. They are not required for basic OAuth implementation in Apigee. The OAuth v2 policy is sufficient for standard OAuth flows. We recommend using these policies for custom token generation or validation logic outside the standard OAuth v2 policy. The HMAC policy computes and verifies hash-based message authentication codes for authentication and application-level integrity checks. The policy is not required for basic OAuth implementation in Apigee. We recommend using this policy for custom token generation, message signing, or additional security measures outside the standard OAuth implementation. If you are generating custom JWTs outside the standard OAuth flow, you might use HMAC to sign the JWTs to ensure their integrity. The SAML assertion policy validates incoming messages that contain a digitally signed SAML assertion and generates SAML assertions to outbound XML requests. This is common in environments where SAML is used for single sign-on, and you must bridge SAML-based authentication with OAuth-based authorization. The access control policy allows you to allow or deny access to your APIs for specific IP addresses. And the CORS policy lets you set cross-origin resource sharing headers for APIs consumed by web applications. This policy is essential when your APIs are accessed by web applications hosted on different domains. CORS is a security feature implemented by web browsers to prevent malicious websites from making a request to your API without your permission. We recommend combining the policies into a shared flow that multiple API proxies can utilize. Unlike a proxy, a shared flow does not have an endpoint and can only be used within the same organization as the shared flow itself. A shared flow ensures consistency, reduces development time, and simplifies code management by centralizing useful functionality in various contexts. This approach helps streamline your API development process and maintains uniform behavior across your APIs. Policies in Apigee API proxies are processed in the order they are configured. This sequential processing ensures that each request is handled in a structured and secure manner. Placing SpikeArrest, authentication, and threat protection policies in this order provides a layered defense approach. SpikeArrest controls traffic volume. Authentication verifies client identity, and the threat protection guards against malicious payloads and attacks. Now let's discuss data masking and hiding. When you debug API codes in Apigee, the content can sometimes contain sensitive data, such as credit cards or personally identifiable information that must be masked. Apigee enables you to define mask configurations to mask specific data in trace and debug sessions. When masked, data is replaced with asterisks in the trace output. You can mask sensitive data and keep non-sensitive data unchanged. In addition to masking, you can prevent sensitive data from appearing in the trace tool and debug sessions by choosing a name that begins with private for your custom variables. A JavaScript policy can remove sensitive data from the backend response before sending it to the software client. Let's move to transport layer security. Apigee provides comprehensive TLS support, allowing you to configure and enforce TLS policies for secure communication. When using HTTPS, the request is securely terminated at Apigee and decrypted for processing before being re-encrypted and forwarded to the backend. However, if additional security is needed, you can encrypt the payload. This can involve encrypting only specific critical fields or the entire payload before transmission. For general encryption, one-way SSL provides secure communication. Two-way SSL is recommended when the client and server must authenticate each other to ensure secure and trusted communication. We recommend using Google Cloud Armor for IP address-based and geo-based access control. Google Cloud Armor is a network security service that provides defenses against DDoS and application attacks and offers a rich set of WAF rules. However, in cases where it's not possible, you can use the access control policy. Let's explore a microservice architecture example that integrates Apigee and Google Cloud Armor for enhanced security and efficiency. Apigee streamlines the process of exposing your services to consumers by implementing a consistent set of security policies across all APIs. In this scenario, Apigee is provisioned within a Google Cloud project, with the runtime set up and peered in a tenant project via VPC network peering. The payments and account services are hosted in a data center, while the money transfer service operates in Google Cloud. To bolster security, rather than sending data over the public internet, you can utilize Apigee as a proxy layer, establishing a direct, private connection to your data center through Cloud Interconnect. Google Cloud. Armor enhances your security perimeter as part of Google Cloud's global load balancing infrastructure. It provides web application firewall capabilities and mitigates distributed denial of service attacks. You can configure rules and policies in Google Cloud Armor to assess every incoming request to the external application load balancer, with automation options available for policy management. Let me show you the request flow for the example architecture. First, the client sends the request to the external application load balancer with the application's credentials, such as a key, token, or certificate. Next, the request is filtered by Google Cloud Armor, which enforces and evaluates the configured security rules. If any rules are violated, Google Cloud Armor rejects the request and returns an appropriate error message and status code. If there are no Google Cloud Armor rule violations, the external application load balancer routes the request to Apigee. Apigee processes the request, executes the security policies, and allows or denies it. From there, Apigee forwards the request to Google Kubernetes Engine backends using internal IP addresses. This communication occurs over RFC 1918 addresses since they reside within the peered network. Next, Apigee sends the request to the private data center backends through Cloud Interconnect. Finally, Apigee sends the request to third-party services through Apigee NAT IP address provisioning. Let's move on with platform security. Apigee's role-based access control (RBAC) system enhances security by providing fine-grained access to develop API proxies and shared flows that allow development teams to work privately and control access to specific environments. Using the platform, you can use predefined Apigee roles for various personas or create custom roles with specific permissions. Advanced API security is an add-on to Apigee focused on premium security services. It monitors your APIs to protect them from security threats, including attacks from malicious clients and abuse. Advanced API security analyzes your API traffic to identify suspicious API requests and provides tools to block or flag those requests if you decide to do so. In addition, Advanced API security evaluates your API configurations to ensure they meet security standards and gives you recommendations for improving them if needed. Thanks for watching. If you enjoyed this video and want to see more, hit the subscribe button and turn on notifications so you don't miss any updates. Please give this video a thumbs up if you found it helpful and let me know in the comments what you think or if you have any questions. Look out for our next video in which we will review the risks of the top 10 API security threats and how to mitigate them.